Today's lesson, we are going to solve inequalities. This is our goal for today. Not only are we going to solve these inequalities, but then look at the directions. After we solve the inequality, we're going to graph our solution and display our answer in interval notation. Now, first thing you'll realize about solving an inequality is very much like solving an equation. For now, just pretend like this is an equal sign and think, how would I solve this equation if this was an equal sign? Well, let me tell you, I'd start by distributing this 2 here. This would become 6x minus 16. Over on the left-hand side, I can combine like terms, the 11x and the 2x. Combine like terms becomes a 13x. And then instead of an equal sign, we have this less than or equal to sign. But for now, I'm just going to pretend like this is an equal sign, meaning I need to balance this equation. My 13x and my 6x are separated by the inequality, so I'm going to subtract the 6x over to the left and make this a 7x. Okay. Likewise, my constant terms, the 9 and the negative 16, they're separated by the inequality, so I'm going to subtract the 9 over to the right-hand side. That makes this a negative 25. Okay, and then my final step, I'm going to divide both sides by 7. And negative 25 divided by 7. You'll notice negative 25 divided by 7 does not come out cleanly at all. Okay, so I'm tempted to just leave this as a fraction. Now, inequalities, right in the answer to this, eventually I'm going to have to graph this on a number line, so it would be wise. I'm going to actually convert this into what's called a mixed number, and it works like this. I'm going to say that, so the answer is going to be negative. Negative 25 divided by 7 is negative. I'm going to say 7 goes into 25 3 whole times with, there'd be 4 left over. So here's how I'm going to write my answer as what's called a mixed number. X is less than or equal to negative 3 4/7. And a quick little trick, I'll show you how these calculators have an ABC button. If I do negative 25 ABC 7, it'll show me the mixed form as well, negative 3 4/7. All right, so this is how I write my answer as an inequality. But now I'm asked to graph this answer. So I'm going to go ahead and put like negative 10, 0, 10 on this number line. Negative 3 4/7. This doesn't have to be perfect, but obviously it'd be between the 0 and the negative 10, roughly about there. Okay, and because of the bar, I'm going to use a full circle because of the bar, and then it's a less than sign, so I need to draw my graph, my shading, my arrow to the left. Okay. Now in interval notation, the way I write this in interval notation, if I look at my graph, the endpoint on the left of this graph is an arrow. That means the left endpoint is going to be negative infinity. Now the endpoint on the right-hand side of this graph is the point negative 3 4/7. That's going to be my right endpoint is negative 3 4/7. So in essence, I've really written my answer in 3 different ways. We have x is less than or equal to negative 3 4/7. And we have that displayed on a graph, and we have the interval notation as well. All right, so solving an inequality is very much like solving an equation with our steps, our combining like terms and distributing. There's just, when we go to show our final answer, there's kind of 3 different ways or formats we can use to show our final answer. All right, now there is one catch. So solving an inequality, very much like solving an equation, except there's one catch, and I'm going to show it to you here in example number 2. So here in example number 2, I'm going to subtract my 6x from both sides of the inequality, and that would give me a negative 4x. And then likewise, I want to combine my constant terms, my negative 100 and my negative 70, so I'm going to add 100 to both sides, okay, and that would leave me with positive 30. All right, so here's the one and only catch of solving inequalities. If at any point when you're solving an inequality, you ever have a negative coefficient and you divide both sides of your inequality by that negative coefficient, what happens is the sign gets flipped. Okay, this less than sign is now going to become a greater than sign. Now 30 divided by -4, this decimal comes out nice and cleanly. So this one, I don't care if you write this one as a decimal or a fraction because it comes out so crisply and cleanly. But let's make a note here. You always flip the inequality direction when dividing both sides by a negative, like in this case, this coefficient of -4. So here is my answer written as an inequality. When I go to graph this, -7.5 would be roughly here. And since there's no equal to bar, I'm going to leave it as an open circle. And you can label it down here if you want to as well. Now, since it's a greater than sign, my arrow, my shading, is going to go off to the right, like this. Now, let's write this as an interval. This graph has a left endpoint. The left endpoint is -7.5. Now, since it's an open circle, I'm not going to use a square bracket. I'm going to use a parentheses. Now, this graph also has a right endpoint. It's this arrow. And anytime you have an arrow as an endpoint, we write that as the infinity symbol. And infinity symbols always get parentheses. Okay, so remember this rule. We always flip the inequality direction when you're dividing both sides by a negative. This was originally a less than sign, but because we were dividing by -4, we had to flip the inequality. Oh, and I'll show you this real quick on example number 2 as well. There's a scenario where you could have solved this a little bit differently. I've seen some students solve this inequality and they'll get -7.5 is less than x. If you ever get an answer where the x is on the right-hand side of the inequality, then you should always flip. When you write an inequality like this, a basic inequality, the x should always go on the left. So if you ever have an x on the right and you need to flip it over to the left and basically switch the sides of these two things, then the direction of the arrow also gets flipped in that case as well. So even if you tried to solve this a slightly different way, the final answer needs to be x is greater than -7.5. You would never want to leave your answer in this form right here. The variable should always go on the left. All right, last example, and then we'll do some check problems. Now notice, this is a compound inequality. We studied this in the previous lesson. So here we're saying that this 2x plus 10 has to fall in the range. The answer to this has to fall in the range between 12 included and 28 not included. Okay? And I know that I need to solve for x, and I know I'm going to do that by subtracting 10, but then the question becomes, where do I subtract that 10 from? Should I subtract it from the 12, or should I subtract it from the 28? And the answer is, we do it to both. In a compound inequality, if I subtract a 10 from the middle, like this, then I'd also have to subtract a 10 from the left and from the right. 12 minus 10 is 2. 28 minus 10 is 18. Now I also need to get rid of this 2. My x here has a coefficient of 2. I know I need to divide this 2 away, but the question is, where do I divide the 2 from? Do I divide it from the left or from the right? And the answer is you do it from both. Okay? And 2 divided by 2 is 1. 18 divided by 2 is 9. And so my answer is that x can be any value between 1 and 9. The 1 is included, the 9 is not. And I promise you, I could pick any number between 1 and 9, plug it into the inequality, and this 2x plus 10 would come out to equal between 12 and 28. Okay, and that's really, if you ever want to check your inequality, just try it. Let me think of a number between 1 and 9. I'm going to use 4. I promise you, if I plugged a 4 in for x, if I were to do 2 times 4 plus 10, without even hitting enter, I know that this final answer is going to be some number between 12 and 28. And it is. It gives me an 18. Okay? As a matter of fact, the 1, if I were to plug a 1 in for x, I would get an answer of 12. If I were to plug a 9 in for x, I would get an answer of 28. And so then any number in between, any number like 5, of course it's going to make the 2x plus 10 fall in this range. All right, so any of these values of x will give a satisfactory answer to the original problem. Now to graph this, so again, I'm just going to label this from negative 10 to positive 10. So the number 1 would fall roughly here. Now this 1 has a bar, so it gets a closed circle. The 9 is roughly here. It does not have a bar, so it gets an open circle. And I'll go ahead and label these 1 and 9. And I shade anything in between them. Any of the numbers between 1 and 9 satisfy the original equation. Now in interval notation, I say my left endpoint is a 1 and my right endpoint is a 9, but since the 1 is closed, it gets square brackets. Since the 9 is open, it gets parentheses. Okay, so there we go. That is all of the examples. This time, there are some check problems I'd like you to try. Go ahead and try these check problems on your own. Here in a little bit, I'm going to have you hit pause and try both of these out. And then when you unpause, the solutions will be available to you. All right, so go ahead and hit pause now and give these two a shot. And here is the big reveal to see the answers. Here are both solutions. Quick note. Make sure on this first problem here, the way I solved it, I had to divide both sides by -3, and so that's going to flip this greater than or equal to sign into a less than or equal to sign. And a quick note, even if you solved it a little bit differently, some of you might have solved it a little bit differently and gotten an answer like this, but we would never want to leave our answer in that form. We always want the x to be on the left, and anytime you flip the x from the right to the left, remember that's going to flip the inequality as well. So no matter how you solve this, we should get x is less than or equal to -6. And then number 2 is another one of our compound inequalities. It ends up that x needs to be any number between 3 and 9.2. You'll notice that the 3 is not included, but the 9.2 is. All right, hope that was helpful. Best of luck on this assignment. Take care.